students, today in this video we are going to study about velocity time graph. So this velocity time graph shows about the acceleration, the different type of acceleration. So here we know that acceleration is the change in velocity per unit time. So here the velocity and time, when we take velocity and time on the graph, then it gives the relation, that it gives about information about the acceleration. So here we are going to study about velocity time graph. So what we will do in the graph, that we are going to take this first graph, that first we will draw a x and y axis, x-axis and y-axis, and the time is at x-axis and the velocity will be at y-axis, and according to that we marked here. So here what happens in the first graph A. So here the time is 5 second. At 5 second the object moves 15 meter per second. Now, so velocity, what the velocity is? 15. Here in the 10, at the 10 second, the velocity is still 15. In 15, the velocity is still 15, and at 20 second also the velocity is same, that is 15. So you are able to see that in every time the velocity is same, and if the velocity is not changing, then there is no acceleration takes place. It means this graph shows a zero acceleration, because according to the time the velocity should be changed, but here in this graph no velocity is changing. So we can say that this graph shows zero acceleration. Now move to the second graph. That second graph shows that the object moves at 5 second in time. We have taken the time on, always take the time at this x-axis and the velocity that is in y-axis. So what happens at time 5 second? Object moves velocity of 5 meter per second. Again the 10. At 10 second what happens? Here the 10 object moves 10 meter per second, then 15 object move 15, and then 20. So you are able to see here that the velocity is changing. First the velocity is 5 meter per second, then there is a 10, then 15, and then 20. So you are able to see that the velocity is changing. It means acceleration is taking place, and this acceleration, there is a constant increase of the value of the velocity. Means there is a increase 5, again there is an increase of 5, there is increase of 5. So a particular pattern you are able to see, that 5 meter per second in every time they are increases. So what we can say, that it shows a uniform acceleration. It shows uniform acceleration. It shows a uniform acceleration because there is a pattern, that 5, 10, 15, plus 5, plus 5, plus 5. So a constant value, the velocity is increases with a constant value, and it is also called the positive acceleration. It is also called the positive acceleration, because the velocity increases as the time increases. So velocity increases as the time increases. So the initial velocity is here is your 5, and the final velocity is your 20. So here what we are able to see, that the initial velocity is smaller than the final velocity. So it shows a positive acceleration also. And it is also this graph is showing us about the uniform acceleration. Now the next, moving toward the next graph. The next graph showing the uniform type of graph. Here the acceleration is taking place because at time 5 seconds the velocity, that is 5, at 10 velocity become 8, 15 become 15, 20, at 20 second it becomes velocity 18. So here this velocity is changing. Velocity is changing. It means this graph is also showing the acceleration, but they are non-uniform because they are not definite pattern. They are increasing. They are first increases. First they started from 5 meter per second at the 5 second, then they get 8, then they are having 15 and 18. So what happens, as the time increases, the velocity increases or decreases, whatever, but in this graph velocity is increases, but there is no definite pattern we are seeing here. Like here we have definite pattern, 5 plus 5 plus 5, in each case it increases, a constant value there increases, but here there is no any constant value, it increases. So this type of graph shows the non-uniform type of acceleration. Non-uniform type of acceleration. Now the last graph, that is your showing the retardation or negative acceleration. So let's see how it shows the negative acceleration or retardation. So here the time, so we always take the time at x-axis and the velocity at the y-axis, this velocity at the y-axis. So when at 0, the velocity of the object is 15. So at the time 0, the velocity of the object is 15. At time 5 second, the velocity becomes 10. Again at the 10 second, velocity become 5, and at 15 the velocity become, at the 15, here you are able to see the 15, the velocity becomes 0. The velocity become 0. So what happens here, the final value we get is 0, and the initial is your 15 meter per second. The velocity is 15. So we know that if the final velocity is less than the initial velocity, then always it shows the retardation or the negative acceleration. So at 15 the velocity becomes 0. So here you are able to see that there is a decrease in the acceleration. So we can say that there is a retardation or negative acceleration. So these are the different type of graph, velocity time graph, which shows the slope. These are these lines, these green lines, these curved lines, these lines, these are the slope of the graph show about the acceleration. So which type of acceleration, what type of acceleration is going, that the graph is showing. So this is all about the velocity time graph.